Good morning, welcome to Relove Guitars. Sam here, and I'm just, before I get going, I'm just moving a few things around. Quick check-in. We've got the Nick's Wingy and Mahogany headless guitar in progress here. I had a total disaster yesterday on this. I think I've said this before. Now, where have I put that thing now? Right. It's rare that I make big mistakes, but yesterday I made one and it's cost me dear. I got all the fun stuff done, all the difficult stuff done on this headstock end piece. So everything done with just careful planning, and I was feeling confident everything was going on its way. So I did my usual thing, as I marked up and drilled my bolt holes for my trademark 2-bolt travel fixing, and then I lined up to put the neck piece in to mark the heel, and then drill the heel put inserts. And like an idiot, I ran straight through into, yes, you got it, the modern side adjuster. Well, I can't describe how, I don't know what the word would be, just fed up. Who's that meowing out there? Somebody meowing out there? You go there? No. Morning rain. We've got our Morris. Anyway, I've lost him. He's gone again. Anyway, yeah. So basically, I've now effectively ruined this neck, which is a pricey mistake. Nick's been very sanguine about it. No, I don't know what the word is. We're going to look at an alternative neck which might suit him better, and I'll carry the cost of it for making the mistake. I mean, interestingly, the funny part is this would probably work with a single bolt. I've actually made it oak casters. Well, this is an oak caster, you know. I've made travel guitars with single bolts before, but it still leaves us with a thing, and the only alternative would be to kind of dummy that one in place, and by the time it's all finished it might look good, but I'm not happy with the suboptimal thing, you know. So anyway, that's gonna sit there until we decide on an alternative neck. And yeah, that's my cost. So the moral of that story really was check your assumptions, because early on in the process, Nick had identified that he wanted, or he'd identified the neck. No, actually we chopped and changed a bit, and then we settled on the neck, and Nick kind of sent me through the spec and everything, and I looked at it, and I didn't look at it from the point of view of the heel construction. And the truth is, that vintage arrangement, sorry, modern arrangement, is new to me. I don't know it. So I just I went ahead with it, and I didn't question what I did or didn't know about that particular construction. And not questioning it early means that I just sort of ran on to the normal part of my process, where I was doing everything else the way, I was checking everything else, double checking. I mean, everything I've done I've double tested. But the one thing I didn't do was challenge or question my own assumption, or even I didn't even recognize my own assumption that this was going to work like a standard neck. It just was blindsided, I suppose you could call it. Anyway, so I just went ahead and let's just take this, knock it off. Yeah, just went ahead and drilled as if it was a regular one, and of course it wasn't. I paid the price. So I suppose it's the old Donald Rumsfeld question, which I don't like to quote a man quite like that, but the Donald Rumsfeld, it's the unknown unknowns that caught me out. what I didn't know that I didn't know. And that's the cost of it. Okay, anyway, it's only a blip. It's just I could do without that, but hey, you live and you learn the hard way usually. In fact, if you don't learn the hard way, you don't usually learn. So what have I got here? Well, I have got Rich's brand new from Anderton's, I think, Epiphone Slash AFD budget guitar. I had this out briefly yesterday to check it over, and it's just very playable. Now you've got a tuner on board here, a little shiny thing that lights up. Those who hate twinkly lights will hate it, but yeah, straight away you hear the nut pinging. Getting it in tune is not easy because of the tightness of the nut slots. So it's not a bad budget guitar. Turn off that battery powered tuner. What have we got? Okay, it's a Sunday, so I'm not going to play too loud, but what I'll notice is that the pickups are quite a long way away from the strings, so they could probably do with raising up a bit, but so just on clean, yeah, not a lot of output because they're so low. So we've got a first fret action that's pretty high. We've got pinging nut slots, which means it's not staying in tune. We've got high action down here. I'm not going to. I'm just getting on with doing the setup mode at the moment. High action down at the excuse me, down at the nut. Now this is too. No, that's not a good use of this magnet. It's too powerful. Go over here. Let's put you on the end of something like that. Right. Let's use a smaller one for holding up my thingy here. Alright, so I'm just going to mark up some numbers. So down here we've got currently a last fret action of actually 3 and 2.5, low A3, high 2.5. Remember it's green we're looking at, and down here it's it's quite a lot higher than we'd want at the first fret. Enough to put it sharp, to make it play sharp. So basically, I'm not going to go into too much preamble about this whole thing. The job here is just to make it play as well as it can, give it a really great setup and then send it on. But important in this is to make sure that also the fret ends are as good as they can be, because right now, actually I won't do that until I've changed the action. Right now the fret ends are pretty sharp as well, so they could really benefit from some softening off. I mean, they've been actually, I don't know, you won't be able to see in this, but there's absolutely there's no sanding or finishing of these at all. It's just straight from the bevel file, and raw as it comes. So the first thing I'm going to do is just to actually take this down to my, in fact my clamps are all getting wet down there, but it's too hot to have the door just closed to keep them dry, so they'll just have to get wet. The first thing I'm going to do is just lower this down on both sides and have a quick look. Not a very smooth operation, I have to say. I mean, this is budget, okay, so it comes in a kit and it isn't very much money at all. Okay, so I'm going to aim for 1.5 as usual, and we'll see once we get there what we get in the way of fret resistance. Okay, just over 1.5. That's about 1.3. That's kind of not bad actually. I can use the onboard tuner. Ooh. Ooh. I don't think this is actually picking the right note up actually. What's this saying? No, sharp, okay. Okay, let's do that. Okay. That's why it's set high. So straightforward stuff. It's what you get with your budget price. You get uneven frets. Well, that's fine. That's what it's here for. I just let's check a couple of things else while we're here. Let's check the neck relief. We know the first fret action is too high, just visually. Neck relief is pretty flat actually. There's barely no give, no curvature at all in that. It's very flat. No reason why it shouldn't be very flat, but we might want to make a small adjustment to that. For which we'll obviously take off the truss rod cover. You can see better there. Yeah, so I've set up one of these before, and it was very it's fun to play, you know. But it's like, this is a really good example of a completely budget guitar, which loads of people, a lot of people have been very judgmental about. You know, it's trash, it's Chinese made, bolt-on neck nonsense, and they hate it. But right, once you get this at a nice low action, there's no reason why it shouldn't play beautifully well. I can never remember which is the adjuster for this, but it's not that one. So I'm going to give it a bit of slack if I can, just to allow it some adjustment or a bit more curvature. Let it pick up. I mean, don't be afraid if you're doing truss rod stuff. Don't be afraid of doing quite big adjustments. You know, there's nothing wrong with doing it until you see a change. Some guitars seem to respond a little bit slower, and you find that they end up kind of continuing to adjust after you finish. But you know, as long as you don't rush things through, you should be all right. Now, the other thing about this is that it's got a plastic nut on there, which as we heard straight away, makes the whole business of tuning impossible. So I've got a lovely pile of replacement nuts, which is part of my setup service. So I propose we replace that with that. Slightly different colour obviously, but vastly superior in terms of stability and workability for setting the action. Now the one thing to note is that having lowered the action, the first fret action will now also change, but we can see where we think it is roughly. Just here, and it's not important. I know what's important is that I'm going to go down to what I want it to be, but so it's way over 5, sorry, way over 0.5. So 0.7ish, something like that, maybe. What's that? 30.4. 4 and 3 is 7, isn't it? Yes, let's try that. Yes, that's 7, so that's about 0.6, which is twice as high as I'd want it for the lightest, lowest playing action. So I'll have my 0.3 out ready for this. I've also got my newly constructed larger. Actually, I think I thought I ordered an 11 gauge, but I think maybe there was only a 12. Anyway, it's all nicely oversized so that when we put the new nut in, nothing should be nothing should be tight and pinging. So the first thing that's worth doing is we've got an action down that end set the way I want it. The thing about doing any changes here, by the way, is this is all interrelated. Those three things, the curvature, the bridge action, or the last fret action as I call it, and the first fret action, you change one and the others change. That's the important thing you have to know. And when things are interdependent, of course, there's no point seeing one or other in isolation. You have to treat them as interlinked. Yeah, interdependent, interconnected. So what I'm aiming to do is work from one to the other until I've got a bit of curvature in the neck, about 0.1 to 0.2 I tend to like, somewhere maybe around 0.2 of a millimetre. I want about 1.5 at the last fret on the low E, and I want about 1.2 on the high E on the last fret, and then up here I want a nice workable nut. I'm looking at this is hoping it's not going to put up any big fight. Thank you. Over the first fret I want about 0.3 of a millimetre, and that's always achieved by working downwards. This is a kind of solid plastic, which is in and of itself not a bad, not totally bad material. Now that it has, downside about this, I might have to try another one. This is actually a taller nut. I remember that from last time. Epiphone have a slightly taller nut. I may be forced to use one of these, secret weapon, or I could create a shim. This is actually quite cool because it's the same colour. Let's see if that does a better job in terms of height. This is also bone. It's just less bleached. Okay, yeah, that's not bad. It's a bit wider too. So let's just check the spacings. The spacings are kind of the same, yeah, with a little bit of excess width which we can take down. So we'd have to just, actually no, it sits almost perfectly as is. Okay, so yeah, there you go, that's a good outcome. A little bit of, maybe a little bit of reduction on the edges here first, tiny bit either side. Interesting too, when you probably can't see it, but when I'm looking at a lot of budget guitars like this, you can really see how much room there is underneath the frets when they're put in, and it's a kind of mismatch between the actual radius of the board and the radius of the fretting insert or whatever device they use. So if we look at this here, that's the board, probably as you'd expect, is 12, and actually what you'll find is, yeah, this is a little bit over 12, tighter than 12, so this is more like a 10, which leaves, in fact that's almost exactly what it is. There you go. So that's a 12. Upon it you've got a 10 radius fret, which means you get a little raise. It sits okay, but you get a high spot. Sorry, they're not high spot. All the way down, it ends up sitting high, and what you've got is a space under there which you can shove a blade under, which is, it's just a mismatch basically. But it's really interesting, because why would that happen in a factory? It should be, of all the things, it should be exactly the same. Those two things should be. And then down here you've got, well, your frets. So what did I say there? 10. So really what you need now is a 10 radius on your bridge, which I'm looking at this, and it's, the bridge radius is hard to do because they don't all line up in a straight line. The bridge radius, I would say, is flatter, so the bridge is more like a 12. Yeah, the bridge is a standard 12. So we've got 12 wood neck fingerboard, 10, which is mismatched between that and the bridge. Sorry, the bridge and the fingerboard are the same radius. The frets are put in at 10. I don't know why. Maybe that's what somebody had in the machine on the day, and they just went and it's all in. So what you've got is a slight mismatch now between your playing surface, which is your frets, and your 12-inch radius bridge saddles. And what that means is that when you get a nice action on the G and the D, it means that your E's on the outside are actually going to be higher. Or put another way, if I set the high E at 1.2 millimeters over the last fret, the gap, where the action on the last fret on the G is actually going to be the same, or could even be slightly less, whereas in fact it should be slightly more if the fret radius was correct, but it isn't. Anyway, there you go. It's just one of those little observations. Now, as I say, I've got a couple of mils to take off. Yeah, now this is actually a tricky thing to do, because if you do it with a file, it never cuts it straight. And you can use all kinds of different files, and I never get a perfectly good result. Don't move, and you don't want to squeeze it too hard. I just want it enough so it doesn't stick out too far. And then actually that's almost about it. Out the way strings so I can feel. These are sacrificial strings, by the way. We're going to replace them with new ones. If I can just get them out of the way. That is about, there's about a hair's breadth that I want to take off on this side here, and we'll be done in that shaping. So it's pretty much a straight in fit, which is great. In fact, it's such a good fit that it almost doesn't need any glue. In fact, if we can get away without glue, it's a much better solution, because it makes it movable for somebody in the future, removable for replacement or adjustment. Well, having said that, it can move around while you're trying to do the slot. So that's just, I feel that's pretty good. And you can before you do anything, commit to where it sits, you can do a quick check of where the strings go and how they sit. And really what you're looking for at this stage is just how they sit space wise down here. Excuse me. So I want there to there, and actually that's about right. Okay. Okay. So what I'm going to do is I will put a tiny drop of. I also have to make sure they clear there, which they do. I'm going to put a tiny drop of glue in there. Stick it down, but not much. Yeah, so that's an interesting one to ponder, isn't it? You radius the fretboard at 12, and then you go ahead and put your frets in at 10. And the telltale sign of that, as you saw there, is the let me just get this right. Telltale sign is, come on. The telltale sign is the the space underneath the fret that you could, if you wanted to, stick a blade in, as I just did. And it's consistent all the way down. You can see that all the way to the bottom. Okay, so when you've glued a nut in, just tighten up the G and the D first. Hold it under pressure so it doesn't shoot one way. Then do the B, then do the A. And then do the E and the other E. Now, being a bolt-on neck, if the alignment of this isn't right, you have got a little bit of leeway to slack the neck off and move it around. So let's see if I can find a note on here now. You can hear straight away that that's a better cut nut than the one that was in there. There's no pinging going on at all. So if we could leave it just like that, even if we didn't do any adjustment, that would actually play and stay in tune better. I will do some adjustment because it's too high for what we're intending. But if you had to do it, it's a better trade-off because the slots are really good compared to the plastic one, and they're not grabbing the strings, which is the biggest 50%, I would say, of what causes your guitar to play and stay out of tune. I'm just looking, this is a fraction high still, so we're going to aim for a nice low action, so we might as well go where we mean to go for this guitar. 1.5. That's 1.5, I'll take that down slightly. That's just over 1, barely over 1. Might be a little bit ambitious for this budget guitar with its mismatched frets. Let's just tune. No pings, progressive tuning. So if you haven't watched any of my videos before, your tuning stability, that's good, I like it, it's a good bit of relief now. Your tuning stability is a product of two things really. First of all, the condition of your nut slots, and secondly, the amount of slack in your strings. Those two are both takeable, careable of here. So that's the plan. Oh, while I'm at it, let's just look at the position of these pickups now, since we've now got the playing action where we want it. So I'm going to go to about 3mm under the string when held down at near the last fret, not quite at the last fret, and the same here, which is closer already now on on the bridge pickup. Okay. Alright, so we've got now 2 out of our 3 components, interrelated components, correct. We've got a last fret action that I want. Excuse me. We've got the amount of neck relief I want. We've got a new nut in, and we're now in a position, sorry, I don't know what's happened here, but we're now in a position to, or now in the place where we want to just take this down to the action that we want. Now I've got new files here, so let's see what happens with these. See how easy they are to use with my new modification. So I've got my 0.3, and I'm going to start with this one, the D, and it's nicely supported here by the oversized gauge, which is fine. Better to be a little larger and room for the clear movement of strings than it is to be tight and constricted. Now here I'm just using the files. Normally at this stage I would be doing a little mixture of things, which I'll show you. Stay there a second. Normally I would be using one of my little new set of Chinese jewelers diamond coated jeweler files. When they say diamond coated, I have no idea if there's any real diamonds involved in this inexpensive unit all the way from China, but that allows me to just run in the slot there and just widen it so that there's no chance of it catching if the slot gets deeper as I'm cutting it. Now with this oversized new set of these things, files, it shouldn't be a problem, but I always use that. I always have that jeweler file handy, because creating a slot part of the way down is always a good way of making sure the slot never actually closes in on the string. Now we're kind of getting close to it. Again, since it's gone in a little bit, I'll use this to just widen out the slot again, so it's nice and free running. Oh, well, I think we're almost on the mark there, so let's leave that. Okay, so we'll put this one, it looks deadly, right, but obviously I can't catch myself on the blades here. They are new blades, but they're 10 for £1, those blades, so it's quite a neat use of these cheap blades, I think, anyway. Right, let's just put them back in and check the measurement first. We're not far off the mark with this one. I might do just a little tiny bit of opening first. I mean, who knows what this is made of. For all I know, the so-called diamonds might all fall off in the first scrapes, but so far they don't seem to have done so. See, I'm always a bit of a chicken. Let's carry on with the other one. I want 0.3. Don't wimp out. Come on, go with your 0.3. I say I'm going for something and then I get nervy and I stop a bit early. Come on, stick with your 0.3s. Go for what you said. There you go, there's your 0.3. So 32, hang back up, we're on 42 now. A little bit more. So I'm always pointing backwards, a bit of a gradient, a bit of a slope. The idea that the string runs up and launches off the front edge of the nut. You can still see the fresh air under there. the reason why these strings get caught in these slots isn't just because, well, it's not always just because the slots are too tight. It's also because these files always bend a little bit and buckle. It's impossible. That's why I've tried to sort of give them a bit of extra support. It's almost impossible to use them rigidly straight the way, well, they're not even straight when you get them, by the way. So I'm pretty close there. So because they're never actually truly straight, it's sort of impossible to make a straight line going all the way through this nut, particularly if the nut's quite deep in that direction. So what you end up with is some kind of wiggle, I suppose, in the nut slot, and that wiggle kind of cancels out any clearance the string otherwise might have. And if the slot curves along its length, then the straight string will get caught up on those wiggles, and that's what stops it from moving freely. Okay, quite like the feel of having these reinforced nut files. I mean, I'm not really sure yet how long they'll stay reinforced, because it's a matter of sticky tape and Gorilla tape and all that sort of usual stuff, but I mean, I didn't want to permanently lock them into place like with some resin or something because I want to be able to obviously take them apart and use the other side once, if and when the first side gets slightly blunt. When it starts to get a little bit difficult to cut, then there's the time to use the triangular file to just ease up the slot a little bit, and it just hopefully just widens it out a tiny bit. We're not far off there. How far are we there? Still a bit of fresh air, but there is there too, and there. Let's have a look. Might just leave it there. I kind of got a, it may not be 0.3, maybe more like 0.4. I just have a feeling like I quite like it where it is feeling. That's all. It's intuitive sometimes. So you can see that amongst other things, the numbers are just a target that not target, they're a guide that I start with, or target isn't the right word. They're just, yeah, a start point really. And then I kind of typically go to when it feels right. And that isn't really numbers based, as you can obviously guess. It's more a feel thing. So these are brand new files, so I'm enjoying the brand newness of them. And these, I have to say, do feel a lot more substantial, bulked out like this. I'm hoping they'll continue to perform well for longer, because these thin ones, they're just impossible for them to stay unbuckled for very long. A little bit more. Okay, that's good. This lamp is hot. It's like the film lights. I'm under the film lights. Okay, so we switch to the 16, we're working outwards to the 12. Oops, missed. Now technically this is wide enough to, if you only just use the file, but like all things, when you cut a slot, it's not that the slot is too tight for the string, it's the slot is the exact width of the saw you're cutting with. So if you're going quite a distance down, that's going to grab the saw. There may be loads of room for the actual string, but it's the cutting process that gets difficult when you are cutting a fair way down into the nut. But it's a temporary thing, because once you've got the slotting the saw out the way, then the string will sit in there with loads of room to spare. There won't be any issues with binding. It's just you can't work a file in a deep slot very effectively, because it's always by definition the same, pretty much the same gauge as the slot it's making. But the point is, it's bigger than the gauge of strings we're going to use. So it feels much easier to use actually in this configuration. It was a good move. Something I never thought to do. Well, they did suggest it years ago when I first got my nut files. I'm going to stop there. It's all at the same sort of height. This corner of the room is roasting. Okay, switch to my next one. I just always have a quick gauge before I cut anything. Have a quick gauge to see where we are, and it gives me a sort of start point, which I know I can sort of do by instinct without getting into trouble. And while you're at it, you might as well move the bulk material with your triangular file. There's no point sawing endlessly into a deep slot with your nut file. If you can, it's better that you get it down to the last part of the operation. But sometimes that's quite difficult to do, and you run the risk of overcutting with the diamond file. So I'm stopping around about now. I'll try my very finest of files. Ooh. Feels quite good in this supported configuration. It's really these thin ones that feel the real difference actually. So I might just stop there. Wrong one. See, that's slack now. Okay, so that's where we run out in terms of fret levelness. So what we can see is the guitar, I've got the action set where I want it. The guitar now won't play at that sort of action, which is no surprise. That's why I do the next stage, which is the fret leveling part. And it's one of those things, if you want to play at 3mm last fret action, that's fine. You've got a guitar straight out of the box that will play at that action. But if you want to spend some time and learn how to do this, then what you can get for your time and effort is you will be able to get a very low playing action, and why not? So like I said, if it's something you have the inclination to learn how to do, it's entirely possible thanks to the miracle of YouTube or my ebook even. But apart from that, it's a matter of time and care, and you'll see that when you've finished, you've got a guitar, a totally budget guitar that is, whilst it's even been fretted incorrectly, mismatch between the fret radius and the neck radius, can still be made to play beautifully well at a really low, enjoyable action, where you'll be able to bend the frets, bend the notes at the top, because they were choking out just then. Now typically you shouldn't have problem doing bends on a radius of, well, 10 in fact. That's actually it's a bit harder. You shouldn't have a problem with a 10 radius, but sorry, a 12, but this isn't a 12, so there might be slightly difficult, might be harder than most Les Pauls. Now, the reason I do that, rather than follow the tuner, is just I find it easier to just take a start note and work off it. That's personal. Right, the thing about this neck is it's quite flexible, so it detunes quite easily if you move it around, but as long as you're not heavy-handed with it, it's not really a problem. Anyway, so I've marked up the frets, and now I'm going to do the fret leveling part of the game, which is going to make the guitar playable at the action we've chosen. Now the point I was making before is typically a guitar with a 12mm, let's put it another way, how low you can set the action while still being able to bend notes on the higher strings, for example, is dictated by the radius. There's a geometry involved that makes it kind of impossible if you have a very tight radius, a more vintage radius, like anything below 10, really 10 or below starts to get difficult, and what happens is you find that there's a limit to how much you fret level. You cannot get the clean bends below a certain action. All right, you can level your frets infinitely, but the geometry of the tight radius frets means you just simply cannot push a bend up the hill up here down to lower anchor points and it clear the fret in front of it if you're working at a very low playing action, which we are. So the tighter the radius eventually forces you to lift your playing action a fraction. So on a 7.25 Strat, for example, you just cannot get down to 1.5 millimeters or 1.2 millimeters on the high E on the last fret. It's just impossible. You have to compromise before that. So this ordinarily would, if it was a 12-inch radius, like a Les Paul typically is, this should be tolerant of a nice low action. But because it's been incorrectly fretted to some degree, it won't allow us to have that. So we may have to because it's 10, we may have to go just a fraction higher than 1.2 millimeters on the top E, on the high E. But that's just the geometry. It's nothing. It's no point. There's nothing to be gained by continuing to fret level to try to get down below that. It's constrained by geometry. Right? If you think of the frets, right? As you push a string, you're pushing it uphill, right? But it's still anchored down there. So it comes off the top of the fret and it goes back downhill, not only to the bridge, but it goes downhill to an anchor point, which is at the bottom end of the hill on the radius that the bridge has. And that geometry will defeat you ultimately. Right, so what I've got here is the tool is telling me I've matched it to the curve of the neck, and it's cutting here, no, yes, tiny bit, yes, no, tiny bit, lots, little bit, yes, no, yes, little bit, yes, little bit. So it's cutting all the way across here, which tells me it tells me I've matched the curve accurately. And now the game is to, first of all, make sure all the notes play, because what it's doing is it's taking down some high spots. That's not bad. I would say that's all playing, but the problem is it isn't going to tell us whether or not that allows us to bend as the string comes up the hill over into what I call the B and the G track. And that's going to become apparent in a minute. There's no point testing bends right now, because in its own slot the E string is all playing. It's when we bend it up into the next track, which I'm going to level now. We'll see whether leveling this track gives us back the clearance to do those bends that we want. So this isn't I'm not pushing really very hard or anything. I'm just trying to let the curvature, or mostly gravity, a little bit of push, and the curvature of the tool sit where it should do and do its work. Okay, and I can stop. And again, cutting lots, a little bit, none, not any on this bit, a little bit now, a little bit, none, some, none, not much, a lot, not much, some. So we're taking off some high spots here, and particularly here. So it's the 15th fret, it's quite high, and then we've got the 19th, 20th as well. But the point out of this is, again, as we go into the B track now, we're checking, does the B string play? That's the bridge rattling. Yes, the notes play. Now, what happens to the E? Okay, now the E is choking out on this spot here, and that spot on there is too high, and if I were to mark it, which I'm not, but if I was to mark it with this, right, that's where it's choking out, so I just let it go back, and that's actually on the G track. You see how it works? So now I'm going to recalibrate by pressing, or putting my little brass nuts back down on the I'm to the north of the G track now, and I'm just looking to mirror or emulate, copy the curve, and that's a little bit over curved actually, so I'm going to take a tiny bit of tightness off that truss rod, and that's too little, so it's absolutely tiny adjustments. So I'm aiming to, whoops, that's tipped over. So I'm aiming to copy exactly the curve of the relief as caused by the loaded strings. Now remember that E string previously was choking out on a particular spot on the G track, I would call it. So we'll do a bit of leveling now. This is obviously, it crosses over, I'm working all the way across what I call the G track. And the idea is that we'll take down any high frets that we have here, and we'll check the bends again. And the idea is to, the beauty of this method, there's lots of reasons why it's good, but one of the beauties of this method is we check the G to play. Alright, we've still got some problems here. Now remember, one of the things I said to you was that because of the mismatch radius, the frets are actually a 10 and this is a 12. We're now probably getting practically as low on the D, we're 1.2, and on the D we are about 1.2. That should technically be higher, but because of the mismatch radius, we've got this flattened effect where the strings are like that. The strings are like that. What's happening? The strings are flatter. Yeah, sorry, the strings are like that. Let's do it the other way around. The strings are like this bar here, and the neck is actually like that. So as you get to the edges, there's a bigger gap, but it's tighter in the middle, and that's because of this mismatch. Now that's telling me we still have some, even in just playing the G notes, we still have some unevenness, which is compromising the G notes at that action. But like I said, technically it's a low action, because it's an ultra low action because of this mismatch. So that's what we're working against. We're working against uneven frets plus some technical inaccuracy in this guitar, unfortunately. But you know, it's good to know, because what you're seeing is the limitations of a budget guitar and what it takes to overcome them. And actually it isn't any particular rocket science to overcome them. It requires some effort and some time and some careful fret work. Now I'm looking at the patterns of wear, cutting I should say, and you can probably see them where the dust is building up. Okay. Okay, see? Opened up. Now that's choking out in this area here. That's the G choking out, bending, sorry, the B choking out, bending across here. Let's just move all those strings, and that is now, as you can see, on the, pretty much on the, it's not very good view, sorry, pretty much on the D track. So we're going to do the same thing as we go across to the D track now. So confident that with this much leveling going on, we're going to clear up all of those bends, and that means we will end up with what is technically a very low action, despite the challenge of the mismatched bridge and fret radius. So that's quite good. But this is, you know, this is, you can try and figure out, or if you know this sort of manufacturing process, which I don't, you could try and, it's fun to try and work out what it is that goes wrong, or why it's not. It's actually the fact that this is fretted in 10-inch radius on a 12-inch board. Excuse me. Won't be an accident. There'll be a reason, an economic reason why it makes sense for them to do that. You know, first of all, it's a budget guitar, so who's going to complain? Nobody. And then secondly, you know, there'll be an imperative, like, well, if we're already set up to fret such and such a guitar, and then we just put this straight on the line, or we switch the line over, and you know, there'll be some reason why it's done. Okay, so you can see that when I come across a bit of squelchy resistance there, i.e. a clearly and evidently high fret, I don't bother doing the bends at that point. I'm just going to work until I get that fret or those frets addressed, and then once they're out of the way, then I'll check the bends, because there's no point, we can't stop at this point anyway, because it's not playing cleanly enough. So it's quite a fair bit of leveling going on here, so we've got some seriously uneven frets. Some people, more traditional guitar techs I suppose, would say with Les Pauls you always have to the only note on there at all. I'll do a tiny bit more. Why not? Let's get it perfect. Yeah, to more conventional text would say, with any Les Paul, you have to add this thing called fall off or fall away, I think it's described as. Oops. And the purpose of that is to kind of iron out or scrape down the last few frets on a Les Paul at this end, which typically, because of the way that in a glued neck Les Paul, the neck doesn't move very much in response to the truss rod adjustment. You tend to get a hump up here. Right, I'm just looking there at this really low action. We're getting some choke there, which is on the D spot again. Well, I remember I said to you the consequence of the 12-inch bridge versus 10-inch fret rack. The consequence of that disparity, that mismatch, is that these two strings here are going to be closer to the frets than the others, pound for pound, or relatively speaking. And that's what we're seeing here. These are actually they're actually closer, so we're still getting that little bit of buzz. So I'm going to do one more in the G track and one more, sorry, yes, once more in the G track and once more in the D track, and then I'm going to live with it. So you can see this is a really elegant method, because you get to work all this out and understand it. The tool tells you what's happening on the on the fretboard, and then the logic helps you work out why it's doing that. And it's doing that partly because of this mismatch. So it's meaning that if I want to play it at this low action, I've got to get this part absolutely spot on with the fret leveling, and that's what I'm trying to do. Now, for a first time fret leveler, this can seem quite daunting, because that feels like a lot of material taken off. But you have to that's the only choky-ish bit there. And basically, I mean, it's ridiculous. If you were to photograph that clearance there, you wouldn't be able to see it. And we'll do the D track now, but if they're still left with that little ziz on the bend, then what I'm going to do is I'm going to just tweak the action up a fraction, because as I said to you, I don't mind accepting that when we're playing with effectively a 10-inch radius, which is nowhere near as accommodating in terms of low actions and bends as a 12-inch radius is, and that's the downside of that's the only. Right, I'm going to go down. I'm going to go a tiny bit up, and I'm going to move on from there. Yeah, so it's the price we've got to pay for their mismatch of radii between the bridge, I should say actually between the fingerboard and the actual neck radius. And like I say, there'll be an economic reason for it. It'll just work out to make more sense in the factory of some kind of reason. Or, you know, who knows, it might be as simple as somebody forgot to change over the little brass insert or whatever they use on their machine. And anything's possible. But it was still playable, as you saw at the beginning, but a relatively high action masks all the issues, and that's typically what you're condemned to when you buy a budget guitar. Nope. And that's what we're doing here to avoid overcoming those constraints. Tiny bit more there. Yeah, so you can see that you could say to yourself, well, why does it take this much time and precision to make it play? Well, the answer is because you're taking a crudely manufactured instrument, relatively speaking, and you're making it play at far smaller clearances and tolerances than it was designed to do. It's simple as that. And this is why it takes the time. It also makes it subject to changes in temperature, quite susceptible to changes in temperature, humidity and so on. So if you do like playing around these low actions, then you have to keep in mind that if say for example the neck relief changes due to a change in relative humidity, for example, that change in the neck radius curve can snaffle a little bit of clearance you had at the beginning, and suddenly you might find that you're buzzing on notes that you weren't before, and that's just the price you pay for such close tolerances or such a low playing action. There's no way around it, and that's, to be fair, why the manufacturers don't want to go near it, because in a sense it's a hiding to nothing. All that will happen is they'll get newcomers to guitar playing, buying the guitars, taking them out of the box in a different environment, and then complaining that they're buzzing and they're not playing. So there's no, it's definitely this sort of tolerance or clearance is definitely something that makes more sense to do afterwards. But you have to understand what's happening. So we've got a fret here. It's that G. It's that G. I'm going to do one more on the G. Again, the tricky area. Oh, I need to calibrate it. If in doubt, if you're using this method, calibrate every time you redo something or come back to do something. So it's a G, it's in the G track, but it's about here. So I've got to kind of concentrate on there. Oop. Clank, that's alright. Any marks will get sanded out, filed out and sanded out shortly, so you can afford to do that. Rattly bridge. Hear it? Right, that's the limits of what we're going to get out of this guitar, I'm afraid. That's just experience tells me that, so I'm going to do a half turn on here. I'm going to check where that takes us to. That takes us to, let's go just under, let's go at 1.4. That's good. 1.4. Okay, that's gonna where it stays. Okay, so again, slight compromise by what? 0.3 of a millimeter. Try and measure that. But that's a sort of judgment call at this point in time, because I know from experience that there's no payoff for continuing beyond the point of no returns. Law of diminishing returns, I should say. So I'm just going to work with what I've got. and it's half, just nearly half on the low low E. We've halved the action on the low E from 3 to 1.5, and we've reduced the high E action by a millimetre. So we've 1.5 off the low E and a millimetre off the high E. I'm just going to give myself a bit of get some of the grime off my fingertips for a minute. Sort that out in a minute. Okay, so that's all we need to do with these strings for now. So off they come. I'm going to double check what gauge they are. So what we need to do at this stage now is to reprofile the frets that we've levelled, and then once we've done that, polish them out, which is a long-winded and boring process, but I'll do most of that off camera. But it just means polishing all the frets out in a series of grits from 600 to 1000 to 1500, and then I'll move on to a micro mesh series, which goes to from 1500 up to 12,000. Okay, so I don't need these. I've got lots of 10s. I think they're 10s. I'll double check now. I've got lots of spares for sacrificial strings, so let's just do that. I'll put these away in a scrap string bin. No, that's wrong. I'm not looking at the right string, am I? I think actually these have got 9s on it. 43.5. No, 10s. 10s. In the metal department. Right, so the next part is we get the marker pen out again, and we mark the frets up again. Now the thing with this fret levelling method is that the frets are now levelled relative to each other when they are fully loaded and in playing configuration. So it's more accurate, slightly more accurate, than doing it with the fret with the neck off, or the strings off and the neck in sort of flattened method, and using the fret rocker. And I like to do it this way because it gives me, it levels the frets with the effects of string compression at play on the relative levelness of the frets. And it's not a massive amount of change, but there is definitely some difference in how frets sit when the neck has been compressed that way by the strings, as to when the neck is just flattened under rest, or at rest I should say. Okay, so on one hand it's a little bit more accurate because of that factor. When you level the frets with the neck at relaxed at rest, and then you put it on the guitar, or you restring it, you're basically reintroducing the compression at that point, and that compression does slightly throw out the relative levelness that you've just achieved with your fret leveling. So it's not a huge amount, like I say, but this is just slightly more accurate because it does it with that compression at play on the frets that you're leveling. But the real reason I prefer it this way is because there's a couple of reasons. One is that you can basically, you only level until you've got the strings playing the way you want them to, and you don't level any more, so you're not chasing some abstract, arbitrary levelness, absolute levelness. for the sake of it. You're chasing only a playable levelness for the action you've chosen, which is a pretty, again, it's what's the value of that? Well, the value is that it saves fret metal, so why not? So the other reason I like to do it is because it seems to cater for all the peculiarities of things like the Les Paul famous hump and so on. It actually takes care of that without the need for this old-fashioned quote-unquote fall away, or fall off, or drop off, or whatever it was called. So, you know, that's just what I've found after doing 600-700 setups this way. So never had to do any fall away. There's, you know, it's not perfect, and it's not utterly flawless in that. I suppose nothing is that's as crude as this. It's a piece of wood with some metal sticking out of it, and there's ambient temperatures and humidities and so on. But it's, as a sort of workable method, it's proved itself to be pretty effective. Now, it's not something, if you're a guitarist who's happy playing it out of the box shop actions, then it isn't something you need to worry about. And if you can do that, and if you maybe learned to play that way back in whenever, in the good old days, good for you. You know, it's great that you can cope with high actions, but a lot of people can't or don't want to, and so what I do is set guitars up for them. So, and part of the process here is getting me some bits of tape cut to size so that I can mask off all of the fretboard and keep it safe. So it's a bit boring and fiddly. So at this point I'm going to disappear, and miraculously we will come back when this is all leveled, all polished out and ready to restring and test play. And I think it will be a nice action. We'll put the bridge back on and the stop bar obviously, and then once we've put the new strings on, I will stretch them out and so that all the slack is missing from them, or gone, so they won't go out of tune. And then the other thing is that we'll, as I'm tuning them and stretching them, keep on stretching, detuning, tuning back up, I'll also be able to listen out for any pinging in the nut slots and cure any of that with a little bit of work with the blade and a bit of 600 grit sandpaper. And that is something I recommend you do, rather than later on when you finish to try and rely on graphite and so on, other lubricants in the nut slots. People kind of recommend that willy-nilly on forums, and it's fine, you know. I mean, it kind of helps if you've got sticky slots, but the reason you've got sticky slots is because the slots are either wiggly and effectively not wide enough for the strings to pass freely, or they're just not wide enough, and you just need to take care of that. There's no, you know, why sort of condemn yourself to constantly adding more goo to try and fix that problem when we might as well take care of it right at the beginning. So that's always my ambition. Now what I'll also do is, as I'm sanding this off, I'm going to make sure that I go down the edges. So when I'm at the 600 grit stage, I'm going to go down the edges of these frets. In fact, I might do it slightly before with the 180 piece. Make a little coil of 180, so that I just take off some of that nasty scratchiness, and then we'll go down it to 600 and so on and so on. So the idea would be to try and get, it's not easy to do, to get a little tube of this sandpaper is quite stiff. There we go. I might have got one. Yeah, so I mean I can do it here with or without them thing. Just while you're at it, if you do have frets that are sharp, get a piece of sandpaper like this and go down the edge of your frets like this. Now it's because they're sharp, they kind of kick up the sandpaper a bit, so you have to be ready to roll it on to the next bit. And you can just see when you're tipping over to just touch the binding, or the lacquer, and that's fine, and you just stop there. But this is getting rid of all of those file marks that were sticking out there, and then we can do something similar to the other end. And a light touch is probably what works best, so that you can do the sanding part without tearing up your material. And of course, it would probably need to move around. It's not very easy to get to some of these bits, so you won't be able to see this very well. But just getting right up there into the bit where probably only your thumb's going to reach. But this is really good for getting rid of those nasty scratches left by the files, or the edge beveling file. And once I've done that, I'll then go back, or as we're going over the sanding process for the actual frets themselves, then I'll make sure I go down the edge here and soften off this with 600 and so on. So that was a good start. Anyway, yeah, so I'm just going to now pull off the specially cut smaller bits of paper, and you can see how boring this gets. I mean, how riveting. And then I shall now, promise you, disappear. I think it's time I went and got a cup of coffee or tea or something. Stick. It's also because it's stopped raining finally out there, and we've got some very wet hammocks and cushions hanging up. Probably need looking at. Alright, see you in a bit. Let us continue. Polished, leveled, polished, reprofiled, oiled, cleaned up, truss rod cover replaced, and now we come to the fitting of the new strings. Ta-da! Ta-da! Rotor Sound 10s. This is the set that you get an extra top E in, so it's always handy because I'm forever breaking them, particularly when I'm using them as sacrificial strings. Often one breaks, so having a spare one, even though it's new and it's wasteful, it's still good to have a spare that you can just turn to straight off to complete that set, so you can do a setup on a guitar. And I think it's a small price to pay to complete the setup. Anyway, so after this today, I think I've decided, trying to think what to do next, and I've actually got 3 necks to refret. Much as I'd like to finish off my SG, it's a bit of a self-indulgent luxury, so I think I better get on with refretting these 3 necks, 2 Cosmoses and 1 Strat. And the reason I'm thinking that is that I can basically do them all at the same time, just have the entire bench dedicated to fret refretting, kind of production line. Although not a production line like this one. A production line where we actually know the radius we're aiming for. Right. So putting on the new Rotor Sound 10s, and double check the action, because in taking the bridge and the stop bar off and dusting and cleaning up, I may well have changed the position of the posts, so it's always worth rechecking, not to assume that they're in the right place. Okay, so at this stage, it's okay to put the strings on, get the guitar under tension, set the action again, and then basically stretch out the slack in the strings, and whilst doing so listen out for any pings from the nut slots. I won't expect many, but there may be one or two, in which case we just get ready with the 600 grit and the blade, and we take care of the width. Now the sun's coming out now, so we're going to start to get hot and steamy in here, so it's probably just as well. I'll open the door in a minute. Limitation on this is obviously the Tune-o-matic bridge is something else that is a piece of kit that I don't like. I think it's a very primitive design, and it's full of inherent problems, but you know, it kind of will it's not a showstopper for something like this, but I personally prefer something like a roller bridge instead, particularly as on something like this Epiphone. The Tune-o-matic bridge that comes with this doesn't have a lot of travel, so the intonation space is limited, and that can actually quite often be a problem when you try and intonate the guitar and you realise that you just reach the limits of what you can do, in which case you just have to kind of give up and accept a compromise, which is not ideal. If you go with something like £15–16 roller, decent quality roller bridge replacement, then you tend to get a deeper bridge long ways, which gives you more travel or more intonation adjustment room, which can, on a cheap guitar, or budget guitar I should say, can be quite handy to have. We'll see anyway in a minute when this we get this plugged in and check the intonation on it. Harley Bentons seem to be, no, not Harley Bentons actually, yeah, Harley Bentons seems to be reasonably well intonated out of the factory. Not sure about Epiphones, I can't remember. I know that to be honest, most bridges that you buy, you know, if you put them into a pre-staggered position, sort of halfway along their length, you tend to find that that's a standard intonation pattern, so it's actually quite easy to preset them before you actually try testing the intonation, and they usually are fairly close, unless there's something wrong with the overall positioning of the bridge, in which case you're facing a different challenge there altogether. Okay, so here are my offcuts into the metal bin. And then the first thing I do is just literally press out all of the string to get as much slack out as possible. Now, a bit earlier on we heard that rattle from the bridge, or buzz from the loose components in the bridge. When you're playing a budget guitar like this, you've got to sort of, it's good to learn over time the difference between bridge rattle and other sounds you might hear, other components that might also rattle. But the bridge rattle is a particularly annoying one that can catch you out if you're not experienced, and you might think it's fret buzz and carry on trying to fret level. Get that one now, last one. Now, just for comparison's sake, I'm going to go with tuning it put pings there. So a ping on the, slight ping on the D and the A, which I'll come back to in case we just need to do a little stretching. And again, at this point I would double stretch the strings again. This is so important, and some people have got really fed up and annoyed about it, like I'm doing some damage to the strings. And so often that what people think is tuner instability or tuning instability, that they often blame on the tuners and then go and replace them with more expensive ones and so on. Often what they're blaming is the fact that the strings still have slack in them, which can take years to come out. And what you'll see is that it only just comes out if you work really hard at it. And while I'm here, I'm just going to do the D and A. Might as well do it now. So all I'm going to do with both these strings is just to slack off the strings, and I just want to use the blade, either end if I like, but it doesn't really matter. It could be the fat end probably on the A, but let's do the sharp end. I'm just going to go into the slot, and I'm just going to rub against the sides. Sometimes it's hard to keep it in the slot. The idea is just to aim to widen it a fraction. I don't really want to deepen it any. And then switch over to the other side. Again, trying to concentrate on width more than getting it to go any deeper, which you don't really want since we've set that already. There's a little bit of leeway that we can afford if it's microscopically. Yeah, I mean, if you buy a micron, you reduce the nut slot, it's not a problem. It's hardly going to make much difference, but you want to get the width right. Like I said before, you go off and play. Otherwise, you'll be struggling with tuning, and if you're new to guitar, which you might be. I'm not saying Rich is, but one might be if they were buying this kit. If you were new, you go to a forum and you say, oh, I can't keep my Epiphone AFD. That's the problem with the bridge. I mean, I punish it when I'm I'm quite harsh on it when I'm stretching, but it suffers over the bridge because it's quite a sharp saddle. But anyway, there you go. So that's why I like to have the set of two spare ones in my kit. But that probably wouldn't have done that if that had been a roller saddle. But anyway, I do punish it a bit, as you can see. Yeah, so often if you're getting tuning instability, people will kind of go off to the nearest forum that they trust, and they'll get all kinds of advice about buying, Goto locking tuners. And the funny thing I realised over time is that because the locking tuner has the word locking in it, it suckers people into believing that's how you keep something in tune, by having locking tuners. It kind of sounds logical, doesn't it, really? But the locking tuner really doesn't have hardly anything to do with that. It helps in the tuning in one little way, in that it has less or far less or no string wrapped around the tuner post. It's good in that sense, but actually it doesn't really. People think it stops the strings pulling through, which is what makes them go out of tune, which it isn't. Right, still pinging there on the D and slightly on the A actually, so I'm going to do a little bit more. This time I'm going to use the fat end of the what's it? That thing, the blade. And again, I'm sort of concentrating on width. That's all. Now this is even while I've used a particularly oversized set of files. So you can see that you've got to go oversized, and you've got to do a little bit of work on the width on these things to get them really running free. But once you have them running free, that's not quite right yet. Once you have them running free, your payback will be in hours of fun playing, and it's staying in tune. Now, one of the things you'll notice when you've got it right is that not only does it not ping, but there's a very distinct sense of linearity. Like that. So when you tune it, it responds in a directly linear fashion, and so it moves in step with what you're doing. If it's stuck, it kind of moves in chunks because it hangs up until the tension's so great that it has to kind of give, and it does so and detunes. You'll get to learn to hear the continuous tuning, and that will tell you. That'll be a good indicator that that the strings are running smoothly through the nut. Now just double check these actions again, in case something's moved. Okay, that's fractionally over. To the end there, that's good. Remember, we had to compromise a little bit with this high E, where I wouldn't want to. I mean, I can test it. Now, I'd also, having done some stretches, I'd also do some kind of strong pulls here, followed by some big string bends as my sort of wrap up to the tuning or slack release activity. And also still run the risk of things snapping. Now I do have spares as well in case I do, but okay. So D again, tiny bit of adjustment still to do. So that's all nicely done. Let's see what the relief is looking like. That's good. Got rattling in the bridge here. Not a lot you can do about that. You just need to be aware of it, because you won't mistake it for something else. You can try and make sure everything's pushed down. Some people, I've heard, put a little bit of glue and other stuff on the actual spring itself. I'm not going to do that on someone's new guitar, but in the past I've put little bits of foam in there. You can put stuff in there that you find into the behind or in front, wherever you can fit it, just to stop this screw rattling. It's the screw that moves. Because they just don't sit there they don't sit under any tension because they're a loose screw. They've got a little retaining clip which never does the job perfectly. So I've still got a bit of hanging up on the D. Partly it's also, you could look at it and think, well, that's partly not helped by the fact that the D string slot goes kind of around the corner, and it could be, oh, it's a danger, it pops out when you're doing this. It's not an ideal piece of engineering in the first place. There's a little bit of play in the tuners anyway, which is not very nice, but the important thing is the play in the tuners isn't actually directly consequential on the tuning. That's okay now. That's where we've got one little challenging fret. That's our compromise, I'm afraid. Then 14. Yeah, like I said, we've got a flatter bridge radius than we have actual fret radius, which is just a basic constraint that you can't really win past on this thing. I'm sorry to say, it's the ultimate kind of limit that we can't get around. Short of pulling all the frets and refretting it, that's the only way around. Well, yeah, it would need to be refretted with a call that's appropriate. So here's kind of, is that, well, that's not the one, but that's the kind of things that I use on my fretting device, press, and you make sure you get the right one. You can fret with anything. It can be the wrong size altogether if you want, but what it'll end up with is a mismatch like this has. Okay, so just a quick check now. It's starting to warm up in here. Time to get outside and take a breather. I'm just going to check the intonation and tweak it if necessary. Yeah, as good an action as I can get given that slight mismatch, which is a surprise. I don't remember it being like that on the previous one that I set up, but you never know. So I'm going to just use my little amplifier. I need my phone for tuner. So we can see it. Can you see it there? You probably can. Now, you'll soon see why I hate the Tune-o-matic bridge. Okay. Sharp. Okay, we'll just hold on that for a second. Sneeze. Okay, so of these three, well, that's kind of bears out what I can see actually. The E, is sharp. Oh, it's closer. Alright, so in the sequence I'd say there's a bigger gap between the E and the other two, and they look about right and they sound about right in terms of intonation. So this one I have to turn it counterclockwise. No, maybe it's the other way. I can never work it out. Yeah, counterclockwise if you're looking at it that way, to push this away, extending the length of the string, which will then be flat. Oh well, maybe it's not. slightly flat, so they need to come towards the nut a little bit more. So that would be with a clockwise movement. And you can see why I hate it, because you actually can't get in really to where you're trying to reach, which is the little screw. And this one doesn't want to move at all, but it's got to. Come on, come towards me. That's a good boy. D needs widening. Forward slightly still. Again, so you're basically turning something that's at the wrong angle, and that's as far forward as this one wants to go. So that's, if I can't intonate that, this is the limitation of the Tune-o-matic bridge. You've just got just enough to intonate this one, I think. Okay, so this now forces me to take the bridge off and reverse some of the saddles, which is why I hate the Tune-o-matic bridge, because as it stands, right, it doesn't have enough range, intonation range. These need to come forward, and it won't let me do it. So we have to take these off. We have to take them all off, which introduces instability, wear, stress into our strings, which is annoying. And have to do it far enough to get the entire bridge off. Then we have to fiddle about with the bridge, switch around, we'll say really 3 of the pieces to make it work. Okay, so we lift this off, and then in the past you have to be very careful, because it's also very easy for this to be pinged down at the floor while you're doing it. Ping down at the fingerboard or the lacquer. Okay, so, wow. So this is lessons why I hate Tune-o-matic bridge. Sorry a minute. Lesson number 1. Okay, Tune-o-matic bridge hating lesson. So you get this here like this, and you go, right, we've got to now somehow remove this little retaining clip, which, believe it or not, despite all of this, doesn't want to come out, because it's actually retaining these little bits. So you have to arse about, if you excuse my German, arse about with this little thing. Now ultimately you end up bending, because it just doesn't want to come out of its little housing very easily, and then when it does, out comes everything else and everything falls apart. Now let's just put that off to one side. So I know I want to now take this little unit, lift it out, turn it round and put it back in. Now this time I've put it back with the basically the angle of the wedge facing the other way round. Now this allows me one thing. It allows me to, when that was the other way around, it was blocking me moving the saddle that way. Now I've put it this way around, I can get right the way up to the edge of here, so it gives me about 3 more millimeters of room. But you would actually think, when you look at the construction of this unit up close, which I can't be bothered to do, or I haven't got a camera right now that will do it, but if you were to look up close at the construction of these little saddles, you'd realise that actually it probably should always be this way round, and every single bridge that's ever been made, every single tunematic bridge that's ever been made, ships with 3 facing one way and 3 facing the other. But if you think about the principle of a string coming up the back of this and off the top for a clean intonation, or clean intonation and clean resonance, this bit should always be behind and towards the stop bar, and yet it isn't. It's always defaulted to 3 strings, 3 of the strings with it, what I would consider the wrong way around. So it's a very stupid design, and here comes Claire while I'm complaining about the tunematic bridge for one more time.
That is dangerous.
Yes, I've had to take this brasket thing apart. And then you get one that is already locked in place, and it won't do. It's starting to warm up in here because
the sun's coming out. Yes, it's very hot,
I'm
steamy
going to
out
take
there.
a stop. I don't suppose our hammocks will take forever to dry out, won't they?
Soaking.
Right, I'll come out and put some sprayer bars in them to get them to
Good idea.
sort of dry out. Okay, so yeah, this is just the world's most stupidest design. So anyway, given that sloping thing I've just mentioned, somebody's going to have to tell me why it's a good idea that 3 of them are in the opposite alignment on every tunematic bridge that ever was built. Plus the fact that, look, typically the number of times I've had to do this for these last 3 strings. Why? Precisely because those bleeding strings are presumably the saddles for those three strings are effectively the wrong way round, and therefore I have to change them to give the bridge sufficient intonation space to intonate where I need it to go, which is what we'll get in a minute. Okay, so fiddly fiddly fiddly. Now you might say, well Sam, if you know that, why don't you start the whole thing by just pulling every bridge apart, and look how crappy these things are, pulling every bridge apart and then switching everything around to begin with so you don't get caught out. And I suppose the answer to that is there's a part of me that thinks, no, I must be wrong. I mean, these Gibson people, surely they knew what they were doing. I mean, look, you just can't even get this thing back on. Now it's scratching the bridge, right? I tell you, I hate them. Right? You can line up the hole, but it won't go neatly back in because it's getting caught round. Guess what? The freaking screws. And then if you can get it round the screws, then you can't get it at the angle it needs to go in unless you actually physically bend it, but I don't even think that's going to go in. No. What a pile of rubbish that is. God, I hate them. I may have told some of you this before, but I absolutely despise these bridges. I think they are the crappiest thing ever made. So theoretically the only way you can get this thing to line up with that hole, well you can't, is if you, how? You can't really. It just will, or it either will or it won't in the first instance. You can't get it to push in there because you haven't got any of the saddles clipped in place. If you pushed it in there, it won't go in because there's not enough room. Hey look, let's do it from this end. That's so much fun. Let's try it the other way around. Pushes it in there, comes all the way around the back here, and you're faced with the same problem at this end. Oh look, how do I get it to go in and yet retain? I supremely hate this. Well, you could say, look, you can take that one out of the way, possibly. Even that won't go in because it's not even bent straight enough to go in. Oh my word. What an utterly despicable piece of equipment. I literally cannot get this thing to go back in, or if I can, or if I do get it to go in, it's completely off because I haven't got the last one in. I ain't going to be able to get that one in on top of there because it's going to get in the way. And then if you haven't got the smallest hands in the world anyway, this just, smallest fingers, this just becomes an utter joke. There you go, let's form that again. Mine, by the time you get there, it's completely grubby again. All the bits want to fall out. Put that in. You go, okay, I'm going to only just touch it in, right? And then I'm going to go in this end. So I'm only just going to touch in that end. Right, so you've got them both only just touched in, but you can't get them over the screws because they won't go in. Oh my God. Sanity. It's hot in here. What is it now? It's 24 degrees, but it's humid. 74, and I am just literally at my end of my tether with this now. How do you get this to go in? You've got no room. It will not, you literally can't stretch those, move those out of the way to get this on first, so you can only put those, push those up against those, and then you bring this round here like this, bending it all the while, right? And now there's a fly harassing me. And you get it round to there, and you go, oh look, I can just, I've got it across the top of all of these, but look, I can't bend this round into a right angle now, because guess what? It's pointing anything but a right angle. And so it's bending away, and it will not go into its little hole. Now I'll tighten that angle somewhat. Let's see if I can get it in there. Oh my God, this is hateful. Honestly, I can't stand these things, as you can tell. Okay, so that's lined up with the hole, and I've finally got it to go back in. I mean, how long do you have to spend to achieve something like that? Thanks, Tune-O-Matic. Like, I haven't got anything better to do than that. You can hear me refraining from obscenities. I hate them. Right, while I'm at it, I'm going to now readjust this one, which needed to be almost back at the front. Oh look, I can fiddle around with this little screwdriver arrangement now, which is also completely cack. So I'm going to try, or I am trying to align these three where I think they would end up being, given that that's coming 2 mils more. Right, let's stick that back a tiny bit. There. There. And there. God, revolting technology, seriously. So, not only is it useless to actually work with as a piece of technology, it's also ridiculous to have to be taking it off and doing this to it in the first place to achieve stand any chance of intonating the guitar. That, you know, that we'd forgotten that in all of my blustering and cursing, or nearly cursing. But yeah, the reason I'm in that situation is not even of my choice. It's because it's a lousy piece of engineering from the start. Right, now, oh yes, we've now got, yeah, thanks to the beauty of the Gibson headstock with sideways motion, we've now got some more faffing about to do with sandpaper. Dear Gibsons, if you want to know why you're going out of business, it may have something to do with this piece of grungy engineering that you really should have done better with a long time ago. Right. So now we're in the position of having to get this all wound on again. Again, all of this that we could do without having to do, but still having to do it thanks to the design of the Tune-o-matic bridge. So everything that follows from that inadequacy or that flaw is all of this, redoing all of this, winding on again. The stress we put on the strings when you have to do that, all courtesy of the fact that it won't intonate correctly without rearranging all the bridge components into a fashion that any sane person would think is at least how it should have been in the first place. That's assuming you were condemned to having a Tune-o-matic bridge. So these are still making trouble. I'm going to do something here which is a more radical solution to that. I'm going to widen both those slots a bit with the heavy-handed file. What am I doing? Come on, get the right note. Okay, still worth fighting for. God almighty. God, it's incredible how hard it is to get this thing to run smoothly. Tune-o-matic bridges. I hate Tune-o-matic bridges. I hate Tune-o-matic bridges. Did I tell you? It's amazing. It still wants to ping. I hate the Tune-o-matic bridge as much as I hate this slot on this guitar. To this one, and it should be just about home and dry. Okay, so while I'm just busy gently stretching those back into tuning stability, let's get this up on here again. Let us check the intonation one more time. How well you can see what's going on there. I'm going to check the neck bolts as well on this in a minute. A little bit of a creak there. Tuner conks out, has to be restarted, and then I look for my big plectrum, which I've now lost. Yep, oh well. Still go back to that A slot, it's unbelievable. They're in position, so that's what we have to do to intonate it, and that's not in tune. Don't like these tuners though. Oh, they're horrible. Right, I'm happy with that. I'm going to spend a bit of time off camera stretching and adjusting, micro adjustments to the slots, but whoa, this is difficult. What I'm going to do actually is I'm going to file off a little bit of excess height off here. There isn't a lot of it. I'm just going to have a look up close. Well, am I? I'm going to look at these slots up close, but I'll do it off camera. I'm going to just work them a little bit more to make sure they stop this pinging thing that's driving me mad. But once that's done, that will be stable in tuning. We've got the intonation right and everything else where we were trying to get to, apart from that small compromise courtesy of the mismatched fret radius versus the bridge radius. Okay, so there you go. You can see that anything with a tunomatic bridge is about enough to drive me to complete distraction on a warm day, getting warmer. Thanks for sticking this out. Hope you enjoyed playing this, Rich. Thanks for getting it sent straight through to me. I wish I could just make. I wish somebody made. I wish Epiphone and Gibson. Maybe it's history now, but I wish they had long since replaced that stupid machine, or that stupid piece of engineering down here. It's just horrible. It needs to have gone long ago. But as you can see, it makes people like me have to struggle with it. I mean, you know, the foolish thing is I keep going back to assuming that it'll be able to reach intonation, because hey, they're the experienced guitar manufacturers. They know what they're doing, don't they? And lo and behold, every single time I end up having to mess around with it. Okay, alright, enough for now. See you later.